Lesson 5.2, the addition rule and complements. The objectives for this lesson is you should be able to use the addition rule for disjoint events, use the general addition rule, and compute the probability of an event using the complement rule. In the last lesson, 5.1, we were working with one outcome. In this lesson, we're going to be working with multiple outcomes. So with that, what does it mean for two events to be disjoint? This means they have no outcomes in common. Another way to say disjoint is mutually exclusive. So in the Venn diagrams below, what does it mean for the rectangle? What does the rectangle represent, and what does the circles represent? The rectangle represents the sample space, and the circle represents the event. What diagram has two events that are disjoint, so nothing in common, and what diagram has two events that are not disjoint? The disjoint is this Venn diagram, and not disjoint. So for disjoint items like this Venn diagram, you find the probability of E or F by taking the probability of E plus the probability of F. This is the addition rule for disjoint events. So our number system consists of the digits 0, 1 through 9. Because we do not write numbers such as 12 as 0, 1, 2, the first significant digit in any number must be 1 through 9. Although we may think that each digit appears with equal frequency, so that each digit has a 1/9 probability of being the first significant digit, this is not true. In 1881, Simon Newcomb discovered that first digits do not occur with equal frequency. The physicist Frank Benford discovered the same result in 1938. After studying a great deal of data, he assigned probabilities of occurrence for each of the first significance as shown below. The probability model is now known as Benford's law and plays a major role in identifying fraudulent data on tax returns and accounting books. Part A. Verify that Benford's law is a probability model. Remember, probability models have to have two things. They all have to add up to 1, and when you do that, they do add up to 1. And all the probabilities are between 0 and 1, or are equal to those numbers, to 0 and 1. Okay, and then Benford's law, use that to determine the probability that a randomly selected first digit is 1 or 2. So what this is saying is we want the probability of 1 or 2. These are disjoint, right? Because you cannot have 1 and 2 be the first digit at the same time. So you can do the probability of 1 plus the probability of 2 from the addition rule that we learned up above. What is the probability of 1? And then 2, add those together, and we get 0.477. Use Benford's law to determine the probability that a randomly selected first digit is at least 6. So at least 6 means 6 or higher. So the probability of 6, or 7, or 8, or 9. What is the probability of 6? So these are all disjoint, so you can write them like this. So add the probabilities of each together, and you should get 0.222. All right, let's think about a deck of cards. We have 52 cards in a deck. What is the probability of drawing a king? It's the probability of E. How many kings are in a deck? There are 4. and there are a total of 52 cards. That's 1 over 13. We did this, examples like this in 5.1. Now B is asking the probability of a king, or which is event E, or the probability of F, which is giant queen, or a jack. So you cannot draw a king and a queen at the same time, and any other combination of these. So these are disjoint. So the probability of drawing a king is 1 over 13. Probability of drawing a queen is the same. When you add those together, I'm just going to write this as 4 over 52, so it's easier to add. That's 12 over 52, which reduces to 3 over 13.